Rule 4, we have the sum and difference rule. So this says if you have a function y equals, and you have like f of x plus g of x, and this could just be like x squared plus 1. You have something plus another thing. How are you going to take that derivative? How are you going to find y prime? Well, you're just going to take the derivative of the first piece. So take f prime of x, take the derivative of the first term, and add the derivative of the second term. So all this says is basically do nothing different. So rule 3 said do nothing different, keep the constant multiple. Rule 4 is the same thing. Don't do anything different. Still bring down the power and subtract one for the new power, except for if they're added, make sure you still add them. Same thing if they're subtracted. Still subtract them. Rule 3 and 4 are kind of nice because they're not really rules. They say do the same thing you've been doing. Okay, let's use this on this first example, which is tricky because of algebra. We have to rewrite it because we have a root and a denominator. So I'm going to rewrite this as 3x to the power is 1, and the root is 2 since they're not written. So 3x to the 1/2 plus I have 2x, and I'm bringing it out of the denominator, so it must be a negative exponent. All right, now I'm going to take the derivative, y prime. I'm going to keep the constant multiple 3 and bring down the power 1/2. And raise x to the what? Again, I'm going to do some subtraction of fractions off to the side. 1/2 minus 1 is the same thing as minusing 2 halves. It's the same thing as minusing 1. So I would have 1 minus 2 is negative 1/2. You always keep your same denominator, just subtract the numerators. So we keep the constant multiple 3, bring down the 1/2 x to the negative 1/2 because we subtracted 1. And same thing here. I'm just going to take the derivative as usual. This is all this says, is take the derivative of each piece individually. So this other derivative, I have the 2 to keep and bring down the negative 3. This is one I could probably multiply in my head. 2 times negative 3 is going to give me negative 6. X to the what? What's negative 3 minus 1? It's going to be negative 4. There is our derivative. And that's a really tough one because of algebra. Calculus is nice. It stays the same. Algebra, you have to really think about which rule do I use for which case. All right. If we do some more. Hey, wait. This doesn't look like a sum or difference, but it is on the homework. So I need to use algebra again to rewrite it to be a sum or a difference. So I need to take each term and actually divide it by x. So I need to do some simplification of this g of x function here. So I'm going to take 4x cubed and divide that by x. I have minus 5x squared. That's going to get divided by x. I have plus 3x to get divided by x, and a plus 10x. Plus 10 to get divided by x. Taking each original term and dividing it by x. And then I'm going to simplify before I take the derivative of this. So I need to keep rewriting it. Maybe I'll write it below. So I have 4x cubed over x, so subtract x cubed minus 1 is going to give me x squared. 3 minus 1 is 2, minus x squared minus x. Divided by x is going to be minus, so you have minus 5x. And then these x's just cancel out nicely. I have a plus 3. And then 10 over x, there's nothing to simplify or cancel. I need to rewrite this in a way that I can take the derivative of it, though. So if it's in the denominator, we bring it up as a negative exponent. Here is my original g of x. All of that work, and we're not done because we did not take the derivative. The derivative means we brought down the power and subtracted 1 for the new power, and we didn't do that yet. Now we're ready to, though. So I'm going to label it g prime of x because I'm ready to take the derivative. Bring down the power. So 4 times my power 2 is going to give me 8. And then I'm going to have x to the 2 minus 1 is just x to the first. So I have 8x. And then here's our mini rule. What's the derivative of negative 5x? It's negative 5. Because if you bring down the power, you're bringing down a 1, which doesn't change anything. And raising x to 0 also is 1. Ooh, back to our first rule. What's the derivative of 3, a constant? It's going to be 0. And then our last term, 10, bring down the negative 1 is going to give me 10 times negative 1, which is negative 10. X to the negative 1 minus 1 is negative 2. So if there's one in the homework that looks like it's division, you need to use algebra to rewrite it because all we have is a sum and difference rule for right now. The next one we have is another one where the homework is trying to trick you. We have a product, two things multiplied, but we don't have a product rule yet. So we need to rewrite this so that it's addition and subtraction. So we're going to FOIL it. We have x times x, which is x squared. My outer term's x times -1 is going to be a -1x. My inner term is 2 times x, which is 2x. And my last term, 2 times -1 is -2. And if you didn't FOIL in high school and you just did regular distributing, you'll get the same answer as me, depending upon what you learned. We should all get the same answer, however you do algebra. So x squared is my first term, and then I have -1 plus 2. 2 minus 1 is just going to give me a regular x. And then we have -2 at the end. Are we done taking the derivative? No, we didn't even take the derivative. All we did was algebra, which again, I said you could have FOILed it, you could distribute it. Algebra is hard. There's so many ways to do it. Derivatives, we're doing the same thing over and over again. Bring down the power. H prime of x is going to be 2x. Derivative of x squared is 2x to the first, or just 2x. What's the derivative of x? Derivative of 5x was 5. Derivative of -5x was -5. And then on the page before we also had 902x. That was 902. What's the derivative of 1x then? It's going to be 1. And then lastly, -2 is a constant. The derivative of -2 is just 0.